Hello again. In this video, I'm gonna talk about the assistant book of the transport phenomena second edition book. As you know, in the transport phenomena, there are many mathematical formulation, derivation, and the solution of this, especially the PDEs, partial differential equations, and other concepts like a vector fields and tensors and divergence and gradients and so on. So I recommend you to study simultaneously this book called Advanced Engineering Mathematics with the Transport Phenomena to understand the concept deeply and properly. So this is second edition by Greenberg. In here, I'm just gonna go over the part and the chapters of the book, what's inside of the book. The content you see as a first part is give you in the first part ordinary differential equations, and the second part in the actually uh, when we go the derivation of the system equations, we can call this the three level and molecular level and microscopic level and macroscopic level. In the macroscopic level, when we derive the equations for the system, for example, for the mass equations, mass balance equation, energy balance equation, mostly we obtain either algebraic equations or when we cancel the accumulation terms, either the ordinary first order or second order ordinary differential equations. And this book, starting with the introduction of the differential equations, and give you some solution of the first order differential equations. It's classified the differential equation like a linear, non-linear, homogeneous and non-homogeneous, and it's give you some solution methods like integrating factor methods and existence and uniqueness for the linear equation, variation of the parameter method, and also application of the linear equations. Give some example, then it's give you some separable equations, and finally in the chapters 2 is give you exact equations, differential equation, and integrating factor. So in chapter 3 is move the higher orders and second order and higher order differential equations. It's talk about some linear dependence and in linear independence, and it's talk about the general solution of the homogeneous equation. Then the solution of the homogeneous equation by the case of the constant coefficients in the subtitles here, and also give some application of this part. Then it's talk about the solution of the as a second case homogeneous equation, but this time non-constant coefficients. And finally, it's talk about the solution of the non-homogeneous equations in here and application of this non-homogeneous equation others. Then finally, chapter 3 is give about the system of the linear differential equations, solutions and existence and uniqueness, so on, and examples. In chapter 4 is give the power series solution, introduction, how we utilize the power series solution for the differential equation solution. Is give you the method of the Frobenius and Legendre function and singular integrals, gamma function and Bessel function, and so on. In chapter 5, it's talk about the Laplace transform, the solution of the differential equation and the system of differential equations. Chapter 6 gives quantitative methods like a numerical solution of differential equations like Euler methods and midpoints rule and Runge-Kutta methods, and application of system and boundary value problems and stability and difference equations. So chapter 7 is give qualitative methods like a phase plane and nonlinear differential equations, so on. In the second part, is talk about the linear algebra. In chapter 8, it talk about the solution of the linear system of linear algebraic equation, like it talk about Gauss elimination methods and some example. And in chapter 9 is the important chapter, talk about the vector space, define the vectors and space, introduce the angle between two vectors and dot product, and talk about the two space, three space, and n space, and talk about the dot product, norm, and angle for the n space, and give up a basic definition and the theorems about the dot products, norm, and talk about orthogonality and normalization, and talk about the generalized vector space, it's generalized the vector space, and talk about the span, subspace, linear dependence, basis, expansion, and dimensions, and finally the best approximation. In chapter 10, it's talk about matrices and linear equations. Let's give the general definition of matrices and give the transport of matrices and determinants and the rank of the matrices, inverse of the matrices and applications and Cramer's rules and LU factorization and change of bases, so on. In chapter 11, the eigenvalue problems, and chapter 12, extension to complex case is the optional one. In chapter 3, actually not chapter 3, part 3 in this book, is talk about scalar and the vector field theory. Is very important part for to understand to assistant for all the this course of transport phenomena. So is chapter 13, differential calculus of the function of several variables, and is talk about the PDEs, partial differential equations, and Taylor series, and mean value problem, and maxima and minima, and it's talk about the vectors in the tree space, dot and cross products, Cartesian coordinates, multiple products with the dot and the cross products. Then the differentiation of a vector function of a single variable, and then talk about the non-Cartesian coordinates, plane, polar coordinates, cylindrical coordinates, spherical coordinates, and transformation between these coordinates. And in chapter 14 is give the definition and physical meaning of the curves and surfaces and volumes, double and triple integrals, and what's curves and line integrals, and surface integrals, and volume integrals. In chapter 16 is talk about scalar and the vector field theory. It's talk about divergence and gradients and curl and Laplacian, and it's talk about very important theorems that are utilized in the transfer phenomena, the derivation of the conservation laws, divergence theorems, Stokes theorem, and other important Green's theorems, and so on. In the fourth part is talk about the other concepts, other mathematical concepts. So chapter 17, actually chapter 18 is diffusion equations is important here. The other wave equations and Laplace equations. And chapter part 5 is talk about the complex variable theory and so on. So in the next couple videos, and actually in 2 or 3 videos, I'm gonna go this parts and chapters by detail and try to emphasize the important part of the important statement into important paragraphs into important sections. They are useful for especially for grad students or undergrad students, no matter, to understand and the modeling of the system and mathematical formulation of the system, solution of this mathematical equation, especially differential and especially partial differential equations, and analyzing of these solutions. All this necessary knowledge we can find in this book, so I recommend to you use this book simultaneously with the Transport Phenomena second edition books. This is also in the second edition. Okay, I hope see you in the next videos. In the next videos, I'm going to talk about deeply what's inside of this book, detailed.